Hello, everyone. Today we will see top 4 man-made miracles. The first one is VantaBlack. This was invented by Surrey Nanosystems. The material absorbs 99.65% of light. These small nodes in the black mesh shown here are carbon atoms. The mesh that you see here, carbon atoms are connected in a tubular matrix. This is the darkest black on Earth. Do you wonder how it looks? What do you see? A surface, or a hole, or a cropped image? This is a circle on the floor painted by VantaBlack. There is a museum dedicated to the art related to the VantaBlack by Anish Kapoor. What do you see in this picture? One black oval and a face? These are two identical masks. One is without paint, and one painted by VantaBlack, looks like an empty space. Here we can see the clear difference between a black paint and the VantaBlack paint. In these pictures, we can see the VantaBlack produced in the lab. Now, the first question comes to our mind is, where can we use it? Let's see. It has huge potential in telescopes and cameras to eliminate stray light and enhance image clarity. This can be used in art pieces, cars, wristwatches, etc. Another use is extreme thermal shock resistance. VantaBlack coatings, they can withstand repeated immersion in liquid nitrogen at minus 196 degrees Celsius and then being transferred to a hot plate at plus 200 degrees Celsius without any effect on its properties. VantaBlack can withstand temperatures ranging from minus 196 degrees Celsius to plus 400 degrees Celsius. The fun fact, scientists in MIT have invented a material darker than VantaBlack, which is yet to be named. Number 2. Aerogel. This is a translucent, solid material. Before we know more about aerogel, let's see its physical properties first. This is extremely lightweight. It is a solid material. It has a very good surface area. It has a low thermal conductivity. It is made by replacing the liquid in gel with a gas. The most common aerogel is silica aerogel. It is such a good insulator that it can take the heat from a torch without any change in its physical properties. A person wearing a suit made up of aerogel can be sprayed by liquid nitrogen at minus 196 degrees Celsius without getting harmed. This is a temperature at which most of the materials freeze and become extremely brittle. Another important property of aerogel is its hydrophobic. It keeps a very thin layer on the substrate and keeps it dry. Here is a very interesting video by Veritation. Let's have a look. They are directly heating the cotton coated with VantaBlack. Using a torch, the temperature is going as high as 907 degrees Celsius, and the person is feeling a slight warmth and not a burning sensation. So did you like it? Do comment. Let's move to our third inventions by humans, the graphene. Yes, we must take its name with due respect. In this picture, you can see a honeycomb-type sheet. There are carbon atoms at the nodes of these hexagons. This sheet is called as graphene. There is a bullet at full speed attacking on it. Can you guess the use and properties by looking at this image? Before we go there, let's see how carbon atom rearrangement changes its physical properties so significantly. Carbon atom has 4 electrons in its outer shell. By rearrangement of these atoms, we get 2-dimensional and 3-dimensional shapes. In diamond, these atoms make 3-dimensional tetrahedral shape and are interconnected by other carbon atoms. Diamond is the hardest material known on Earth. Another allotrope of carbon atom is graphite. The graphite is arrangement of carbon atoms in hexagonal shape, and the 3 atoms are connected by covalent bonds in a 2-dimensional layers. These fourth atom is connected through weak intermolecular force in other such layers, making it a three-dimensional structure. This is the primary reason the graphite is slippery in nature. The graphene is nothing but a single layer of graphite. It's basically a two-dimensional structure. The structural properties of graphite and graphene are entirely different. The graphene is the strongest material known to us till date. Since the fourth electron of the carbon atom is free in graphene structure, it is the best conductor and is used in superconductors and smart screens. Here is a brief comparison of graphene and steel material properties. Look at the density, which gives an idea of unit weight of material in a given volume. To appreciate these values requires slight understanding of mechanics. However, for most of our audience, it can be noticed from this table that properties of graphene are much better than steel. Let's see some interesting facts about graphene. If we take 1,000 sheets of graphene, with each sheet having an area of 1 meter by 1 meter, what will be the equivalent number of the normal A4 sheet that we use for printing? Just one sheet. Now let's take a sheet of graphene which has an area equal to a football field. What will be the weight of it? Any guess? It's 1 gram, yes, just 1 gram. Now let's take a hammock. The size of the hammock is 1 meter by 1 meter. Now there is a 4 kilograms cat sleeping on the hammock. If we want to make a similar hammock from a graphene, such that it still supports the weight of the cat, any guesses? It will be the weight of 1 whisker of the cat. See what is a whisker in the inset picture. So are you thrilled to know more? Hold on, let's move on to the next invention. Number 4, self-healing concrete. When certain bacteria are mixed with concrete, it is called self-healing concrete. Meanwhile, the bacteria. There are many names of self-healing concrete, also known as self-repairing concrete or bioconcrete. The autonomous repairing concrete has the ability to mend its cracks automatically. This property of concrete can be very useful for concrete in aggressive environments, where cracks can lead to ingress of harmful chemicals in the concrete and may lead to corrosion of reinforcement bars. For example, dams and reservoirs, nuclear structures, bridges, ports, and harbors, structures under soil such as pile foundations, etc., tunnels, etc. The following are the important benefits of self-healing concrete. The concrete becomes more durable. There is an increased resistance to cracks. The lifespan of the structure increases, reducing overall costs and maintenance costs. When water enters in the concrete through crack openings, these bacteria expand in volume and fill the crack. It looks like he is satisfied with this. The self-healing concrete is economical in the long run. In the research, it has shown that the presence of these bacteria only affect the initial strength of the concrete, but the final strength of self-healing concrete is much higher than the ordinary concrete. If you like this content, do hit like and press the subscribe button. Thank you.